Welcome back to Pencil and Paper. We're doing episode 7 today. So let's start off with problem 1.
The problem 1, this conversation appeared in my Math 210 class this year. Because one of the students, when they see this problem, his answer is indeed the least common multiple of 78 and 91, which happens to be the correct answer for this problem. So what's wrong with this solution? Why this is not an answer? 78, 91, which is 13 times 6 times 7.
546.
So they are running on the track, right? So they catch up again. So if we change this number to what? What do you guys think? Replace this 78 by what? 65? Now what's the what? Least common multiple. It would be 13 times 5 times 1, 7, which is
455.
455. Right? So if assume one of them is even faster. He finished this track in 65 seconds. The other one finished the track in 91 seconds. Then actually this is not the answer of our current problem. Because what's the easiest way to see that?
Well, if it's for 155 seconds, one runs 7 laps and one runs 5 laps. So you should take it twice instead of once.
That's very good. So that's a very insightful explanation. In this many seconds, the first guy, he ran 7 laps. He ran 5 laps. So there's no way suddenly they overtake each other with 2 more laps, right? So somewhere they must have already overtaken once. And if this is linear, we know actually the other taking places must be what? Half of them, halfway, right? So the correct solution for this should be what? Suppose it takes t seconds, then t over what? T1, which give you...
So that's the number of laps that the first person does.
No, laps. The first person, fast kid. Right? Minus t over t2 should equal to 1. Right? So if we solve this equation with 78 and 91, we got 540. And if we solve this one, then we get a different number. A number that is different than what? 455. Actually, it's half of 455. Yeah. Right? So that's the logic flaw over here. So actually, this guy answered which question? How do we change the question so actually make this is not the correct answer, but his idea is actually correct?
So essentially, he's trying to find the least time which it takes for all of them to run an integer number of laps. So it's like the first time whether meet at when we meet at the same point again.
Yes. Yeah. So he answered the question is actually how long it will take for them to what? Come back to this starting point again. Right? If that's the case, then he has the correct answer. Right? Okay. So even though you get the right answer doesn't mean your solution is correct.
Your logic
is correct. And the study method is very important with logic. And that actually happens to our second problem also.